Hello students and welcome to your chemistry lesson. In today's lesson we'll be looking at the atom, and under the atom we'll be looking at classification of elements. I'm sure you know that elements are made up of atoms that are totally the same. For example, the oxygen element is made up only of oxygen atoms. Now, in today's lesson we want to know how these elements are classified. The main classification of elements is simply in two, that is the metals and non-metals. So in this lesson we'll be just looking at a brief on metals and non-metals, what they are, what makes them metals, what makes them non-metals, and then we'll look at some examples of what metals are and non-metals are. So what are metals? Well, metals are elements that form positive ions. They are elements that form positive ions. How do they form positive ions? Well, they form them by losing electrons. If you're with me the last lesson, you agree with me that we talked about most elements being present as ions, or I said being bonded to something, right? Yes. Now, that state in which an element is ready to be bonded with another element is known to be an ion. Now, let's say the element calcium that we looked at, right? Its electronic configuration was 2,8,8,2. There was that 2 electron that was in the outermost shell, right? Yes. Now, when a metal wants to bond, it will lose that electron, or it will lose the electrons in the outermost shell, and by that it becomes positively charged. We'll later look about this becoming of the positive, negative charges, yes, later in this lesson. Said we'll look at examples. So apart from metals being elements that form positive ions, they are also known as cations and electropositive elements. So the other name is cation and the other name is electropositive because they become positively charged. Cations because they are attracted to the cathode during electrolysis. Later in chemistry we'll look at electrolysis and you know how this name cation comes about. Then last but not the least, metals are generally elements that have got 1 to 3 electrons in the outermost shell. So let's say the element lithium, which is the third element on the periodic table, when we make its electronic configuration, it will have 1 electron in the outermost shell. Calcium had 2 in the last shell. Aluminium has 3. So you see, most metals have got 1 to 3 electrons. With that said and done, now let's look at non-metals. Non-metals are just the opposite of metals. So the first thing will be that they are elements that form negative ions by gaining electrons. You see, we're just negating the main words. So elements that form, what's the opposite of positive? Negative, right? What's the opposite of losing? Gaining. So they are elements that form negative ions by gaining electrons. Then the other thing about nonmetals is that they are also known as anions and negative elements. We'll also look at why they are called anions when we look at electrolysis, but electronegativity is just caused by them forming negative ions by gaining electrons. See, it's just a combination of electron and negative. Yeah. Then the third other thing you should always remember about nonmetals is that they range between 5 to 7 electrons in the outermost shell. So most nonmetals, they are in this range. Most of them you encounter are just between 5 and 7. There's also another thing you should always note. Metals and nonmetals react in a way that when the metal loses an electron, it gives it to a nonmetal so that they bond together. We'll be looking at bonding in our next chemistry lesson, so be sure to be there so that you can know how the change occurs. Yes, so that's basically about the metals and non-metals. That's the basic information you need to know. So now we said we'll look at examples, right? Yes. So now let's look at these examples. So the first example we're going to look at will be involving metals. We'll look at the metal lithium. If you can remember, I said lithium is the third element on the periodic table, right? Yes. So lithium in its elemental state will have the electronic configuration of 2, 1. You agree with me on that point, right? Yes. And so if we draw its electronic configuration, it will be looking like this. 2 electrons in the first shell and 1 in the outermost shell. Now, we talked about metals being elements that form positive ions. And they form positive ions by doing what? Losing electrons. So, there will be a transformation process when this lithium loses an electron. It will be called a lithium ion. We said lithium on the periodic table will be drawn like this and will have the electronic configuration 2, 1, right? But when lithium loses an electron, its electronic configuration changes because it loses the electron or electrons in the outermost shell. And so this will be lithium's ionic electronic configuration. This one is lithium's elemental electronic configuration, the electronic configuration for the element lithium. But after it gets ionized, it has the electronic configuration of an ion. So this is basically what we meant when we said metals are elements that form positive ions by losing electrons. So you might be asking, well, what does forming of a positive ion mean? Well, I'm sure you can remember that we said protons and electrons are equal in every element. And so when lithium loses one electron, there will be more protons than electrons. And so the charge of the whole element changes and it will become positive by 1 by one proton. You see, there will be one extra proton which will give it its charge. And as you can see in the symbol which shows lithium ion, there's one plus sign. We don't indicate the one, just like we don't say 1x in math. So even in chemistry, we can't say 1 plus, we just say plus because there's one extra proton. So now let's look at another example under metals for us to get even more understanding. This time we'll be looking at the element magnesium. I'm sure by now you know the first 20 elements. And so magnesium is the 12th element, if you can recall. And so it will have 12 electrons in its elemental state. And so its electronic configuration will be 2, 8, what? 2. Yes. And its electronic configuration drawn will look like this. And so when magnesium undergoes ionization or simply loses electrons that are in the outermost shell, what will happen is that it will form a magnesium ion. You can see that for the abbreviation of the magnesium ion, we've got 2 plus. If you can relate, this is because there are 2 electrons that have been lost, or simply there are 2 more protons, and so those 2 protons give a charge of 2 plus to the magnesium ion, and so its electronic configuration in the ionic form will be 2, 8. And you can see now that after an element has been ionized, both the duplet rule and the octet rule have been satisfied. The duplet rule stated that the maximum number of electrons in the first shell is 2, while the octet rule stated that the maximum number in the last shell should be what? 8. And you can see there are 8 electrons in the magnesium ion. Now, let's look at nonmetals. We've looked at how metals lose their electrons and now they form ions, right? Now, even nonmetals form ions. The only difference is that they form negative ions. Let's say we had the element oxygen, which is the 8th element, and so it will have the electronic configuration 2, 6, and drawing that electronic configuration will give us a diagram like this. 2, 6, 1, 2, 3, 4, 5, 6. So it's got 6 electrons in the outermost shell. Now, you can remember that we said nonmetals are elements that form what? Negative ions by gaining electrons. So, if a metal and nonmetal were to be joined, the metal would give its electrons in the outermost shell to the nonmetal. That's basically what happens, Yeah, when we look at bonding, we'll understand all this that we're talking about, the gaining and the losing, yeah. So after now, when oxygen becomes an ion, it will form an oxygen ion. In this case, it's different. You see there's a minus in the abbreviation, so it will be O2 minus. If you can remember why our metals had 2 plus, I'm sure figuring out why nonmetals have minus won't be a big deal. Well, if you still can't figure it out, it's simply because now the element will have more electrons because it gains. And because it gains, it will have a negative charge. And so it will have two electrons that it gains from somewhere, which is usually a metal. And because there are more electrons than protons, it will have a negative charge. And that charge will be 2 minus because it gains 2. And you can see now also in the nonmetals that the duplet true and the octet true are satisfied, right? Yes. So this is simply the point of ionization. It's to make elements more stable. When we look at the periodic table, we'll find out why the group 8 elements are known to be stable and why they do not undergo chemical reactions to make them stable. So now let's look at another nonmetal, which is no other than chlorine. Chlorine has got 17 electrons. So its electronic configuration will be that, and drawing its electronic configuration will be 2, 8, 7. In the diagram, you should note that the second shell is not drawn. We only have the first and what? The outermost shell. So when chlorine undergoes ionization, we will see that it gains electrons so that the octet rule is satisfied. There are 7 electrons in the outermost shell. So for the octet rule to be satisfied, we need one more. Right? Yeah. So the ionic form of chlorine will be chlorine with a negative sign, having that it will gain an electron and have more electrons than protons. And note that it will only have one electron more than the protons, and so its charge will be simply minus, or 1 minus if you may need to understand why it's minus. Yes. Drawing its ionic configuration, it will be like that. Again, I say, note there's only the first shell and the outermost shell. With that said and done, that's all for today's lesson. We've looked at classification of elements. Be prepared for our other chemistry lesson, which we'll be looking at bonding.